I know some people are here for the first time. So I'm Ivan Sergienko, and me and Matt Park here for organizing the iOS KW. This fall, we're kind of excited to restart this again. So we're really happy to see everyone here. We're trying to kind of like keep this going. I know we don't have like a ton of people attending. We want to see like this room packed with people and see people like fighting for space. So if you know any developers, if you're working in a company with other mobile developers, and you want to like, for example, host a meetup, or you want to bring your friends here, or you have some suggestions on how we can do it, maybe let's switch it up, maybe like, screw it, let's just go for beers once in a while, or let's keep going with this. I'm really happy to hear your suggestions, so hit me up in the meetup, or email, or whatever. Or we can chat after this. I'm going to try to blast through this pretty quickly, and I'm going to leave some room for discussion and questions, maybe in the middle or at the end. And then we're going to get pizza around 8. We can hang out here. We can go for beer afterwards. Up to you guys. So, as I mentioned, my name is Sergienko, and I work at TunnelBear. TunnelBear, we like bears, and we like security. So we originally started by providing a VPN service. We branched into having a password manager app as well, called Remember. We've also been acquired by McAfee, so we're now in the division of McAfee, which is arguably the world's oldest cybersecurity company. So security is what we kind of we're branched about. So beyond ATS and certificate pinning in you is the name of the topic. If you don't know, if none of these words make sense to you, hopefully by the end of the talk, it will all make sense. And the reason why I wanted to do this talk, actually I was thinking about this for a while, is usually at meetups, we like to talk about exciting things in iOS, like UI, animations, like other cool stuff. Networking can be messy, and security is not as exciting, but it's still really important, especially for our users. So let's talk about stuff. So what is ATS? Security and privacy has become really important in today's world, and Apple recognizes that probably better than most companies. So they have kind of demonstrated that recognition by releasing ATS. So ATS is App Transfer Security. It was introduced in iOS 9 and macOS 10.11. And at the very basic level, what it does is prohibits the use of plain text protocols in your apps. So you really have to go out of your way to use HTTP. It kind of enforces HTTP as best practices. So it makes sure that you don't use some weak ciphers that are known to be broken. It encourages EFS, which is perfect for secrecy, which means that if your key has been compromised, while the data that's been sent previously might have been captured, is not at risk. So it does all of these kind of good things. And basically it's enabled by default. Again, you have to go out of your way to disable it, and if you disable it, you have to put some exceptions in your view list that will be looked at when the app is being reviewed. So just don't do anything and you'll be safe. Well, there are some issues with that. So the problem is HTTPS is all great, but it's not immune to certain attacks. So it's not immune to the man-in-the-middle attack. When we talk about security vulnerabilities, some of them might sound like really far-fetched and like very theoretical, but the danger is actually real, and it's more common than you think. So when you use HTTPS, don't always assume it's going to be secure. So HTTPS relies on certificate authorities signing these certificates, and they're run by people like you and me, and that we fuck up occasionally. Sorry, I meant like mess up, and sometimes they get compromised. There are some really hilarious examples I'm going to talk about later, and some CAs are not to be trusted, and also it's possible the user device might be compromised in multiple ways, which is sometimes not obvious, but very common. And certificate pinning is a technique meant to kind of mitigate these attacks. Now, certificate pinning is not going to, it's not like some kind of magical bullet, but it is very effective at stopping most of these attacks. So how does it work? Okay, so I have this amazing diagram. So this, let's look at like this icon is your browser, Safari, or your application, and it talks to a server. How does it know that the server it's talking to is legit and it's not somebody else posing as a legitimate website? Well, server has a certificate. And usually when server presents a certificate, it presents a certificate as well as a certificate chain that links it to a root CA. So what your browser or your application does, well, not your application, it's old iOS code. What it will do is, first it will verify that the server certificate is indeed signed by the intermediate certificates. And then it will verify that the intermediate certificates have been signed by the root CA certificate. Now, root CA is the certificate authority. Being the authority is, this is an organization that we all trust to issue the certificate to the right person. So for example, if I'm going to go to Matt and issue him a certificate for me, it will try to verify that, the right person is requesting that certificate. Now, this process can sometimes be bypassed, but in most cases, it does work. Now, the question is, how does your device or your browser trust root CA cert? Well, so actually, what turns out is your device, or in some cases your browser, will already come with a list of trusted root CA certs pre-installed. So it's a matter of basically looking it up and verifying that it is the right certificate. So once this kind of chain is complete, and this chain can be cryptographically verified, so it's known to be secure, then of course we can trust the website. Now, what happens if you try to bypass this? So for example, you have the server certificate, looks good, has an intermediate certificate, but then it was signed by some unknown CA, or maybe by yourself. Well, what's going to happen is, it's not trusted because you don't have that root CA installed on your device. And the browser is going to give you a warning and not allow you to go to the website, or you'll get this ATS message that says that there's a problem verifying the certificate. So, how does a man-in-the-middle attack work? So one way to do it is to somehow install to make your device trust a rogue root CA. So what you do is you kind of establish. So you install their certificate on the device. Now it seems like it's pretty hard, right? So like you have your phone. Somebody would have to take the phone away from you, unlock it, install a certificate. But actually, it's pretty common. So, for example, if you work in an enterprise environment, typically what will happen is your device might be managed by MDM. I don't remember what MDM stands for, but it's a way to basically manage iOS devices in an enterprise environment. And as a part of the MDM profile, you can install any root certificate you want. You can also trick the user to go and you can actually email on the certificate. Now, since recent versions of iOS, it actually makes it kind of harder to, even if you install a trust certificate, you have to go into your settings. That's kind of buried pretty deep in, and you have to enable trust for that certificate. But you can do it, basically. And of course, we're not talking about iOS, it's kind of like the wild iOS. You can install anything, anywhere. But I worked for a company called Blue Code, and one of the things that that was their offering was being able to inspect HTTPS traffic. And how do they do it? Well, they basically, when you have an Blue Code device in your network, you make sure that all the computers in the network run a certificate that basically is a Blue Code CA. So basically, you establish this trust between a rogue CA, and then it all checks out, and you trust whatever certificate. Now, there's another way to attack this, and it is to basically compromise the root CA. So in this case, For example, you steal root CA's private key, or you're just a rogue employee working for that CA, and you go and you kind of issue certificates willy-nilly without duly verifying them. And then again, from your computer perspective, everything's fine, but you've been compromised. So, what are some real-world examples? One of the most common one is the DigiNotar breach, and that was, I think it was a Dutch CA. They've been hacked, and apparently that hack was being used to target something like 300,000 Gmail users in Iran. So we don't really know who was responsible. There are some suspicions that it could have been the Iranian government. Some people say it could be NSA or somebody else. We'll never find out, but we know that around 300,000 users could be compromised. And you can imagine if you are a dissident in Iran and the government gets a hold of your Gmail contents, you're probably not going to have a good time. Another example, Symantec. Symantec, by the way, bought Blue Coat, so it's close to heart. Basically, they have an office here in Moreland now. So they've been caught issuing 108 certificates that were not duly verified. So basically, it's literally somebody came to them and said, "Give me a certificate for this website," and they're like, "Okay, cool, there you go." Another example, which was like completely insane. Trustico, which I think is they're kind of like the reseller, or they're like one of the minor CAs. So he went in and he emailed a private key for that CA over just plain email, no protection, no anything. So as a result, over 23,000 certificates had to be revoked because they couldn't compromise. So go ahead.
Do you know if he got phished or was it just like carelessness?
To be honest, I don't remember the details now. I think it's just literally not thinking. I want to say stupidity, but like I want to give the person the benefit of the doubt. Yeah, that was like the most like wow of these cases.
I don't remember the details, but there's some other news around the time where it's like, yeah, that guy was not competent. Like,
yeah. I think he thought it wasn't a big deal. He was like, I don't care, I'll send you this private key, it doesn't matter. And everyone's like, no, that matters.
You know what? I mean, like, I can understand that. Like, I've done a few things where, like, I would send something like, oh, I wasn't supposed to send that. Let's have to revert everything. So, yeah. Again, bottom line is CAs are run by humans. Humans can be phished, or they can just, do stupid things. So, this brings us on to certificate pinning. The concept between certificate pinning is actually pretty simple. So what you do is you include a certificate in the application bundle because supposedly you are the owner or you work for somebody who owns the website. You have access to the certificate, and actually the reality is you can pin any site's certificate because this is the public certificate you're pinning. So you can just go. You can run like a shell command to extract any public certificate from any website and pin it in your app. So, but there are some caveats to that. And you can hook into the network calls so that whenever it is time to verify the server, you basically take the server's public certificate and compare it with the one you have. If they don't match, it's up to your app to decide what to do. Just to demonstrate, kind of like reiterate on that. So we have some fake certificates. Your browser doesn't know it's fake because there's a compromised root CA, so your system trusts the certificate. But then you say, let me just double check this, and they don't match, and you are safe. So let me do a quick demo to kind of demonstrate how it works. Hopefully it's going to work. So I have this, I'm using this app called Charles, which is basically a debugging proxy, which can man-in-the-middle HTTPS traffic. I used to use another app, but its creators, I guess, went out of business, so I'm going to as well. So let's see. Oh, there you go. Say hi to Charles. Let me just filter the traffic. I have made an amazing website. Best website of all time, I believe it's .com. It's going to filter traffic going to that website.
That the way it was available? Jeez.
I can, we can talk about the price. Potentially for sale. Okay, so I have my application. Let me just make sure I'm on the right branch. Yes. Okay, so I have made a very, very simple application that all it does is, it's called a demo app, very imaginatively. And all it does is it uses Location Manager to track the location of your device. And every time you get a location update, it will post this update to my API of the best website of all time. And because I didn't have time to do anything creative, the website will just basically echo the location back to the app. So this, again, I'm using HTTPS here. I didn't do anything special, so let's see if we can intercept this traffic. Okay, so there is no UI, so UI isn't really the fun part. So you can see there's traffic going, so the API is echoing back my location, which is simulated because it's a simulator. Let's see what Charles is up to though. I'm not sure, it doesn't seem to be doing much. Is it? Interesting. Okay, well, I wasn't prepared for that. I wonder if this is because I have Telegram on. Okay, let's try doing this. Oh, look at that. Yeah, that was because Telegram. That's interesting. Okay, but if you can look here, you'll see that Charles is actually intercepting the requests, and if I look at contents, bam, I see my location updates here. Now, of course, this is just a demonstration. This is a special debugging software installed on my computer, but again, it works by basically installing a process certificate in my keychain. So if somebody were to somehow get a certificate in your machine, they could easily compromise the traffic. Now, let's go back to Xcode. Stop this. And let's take a look at a very simple implementation of certificate.
Hey, Ivan,
Yeah.
how many apps have that vulnerability right now?
Well, I mean, first of all, I don't know if, some people are like saying, well, that's not really vulnerability, whatever. I don't have numbers for you, but I would say that probably the majority don't. Because it's not something that, again, it's not like an iOS 101, or it's not something that's generally on everybody's mind. And there are some complications with certificate pinning that I'm going to talk about later, so there are some trade-offs for this. So having said that, probably not enough is the answer. Okay, so what have I done here? First of all, in my resources, I've included my public certificate. It's in a binary format, DER, because that's how I'll show you later. And there isn't really a lot of changes to my code. So this post update is still the same. The only thing that I'm doing here is, instead of just doing, so here I create a URL request, right? So I'm just using the URL session APIs, it's all standard stuff. But what I'm doing here is, I actually create my URL session here, and I pass in my custom delegate here. It's URL session path delegate. And what it does is, this is kind of where all the fun part happens. So we basically override, we implement the URL session did receive challenge completion handler delegate method. It's quite a handful. So that's basically it. So this gets called whenever networking APIs are validating a server certificate. And what we do here is we get the challenge as a parameter. The challenge has this protection space and it has a server trust. So server trust is it's difficult to explain what it is, but I think of it as like basically this is all the information I have about the server, and this is what I'm using to determine if the server is trustworthy or not. So what we're going to do is we're going to evaluate this trust. Now, if for some reason I'm not getting server trust out of here, we just say well, I can't access server trust, so we just cancel the request. Otherwise, we will evaluate it. So what does evaluate actually do? So we get this trust. And first of all, we need to know beforehand how many certificates we have in order to extract them. So I call the sec trust get certificate count. If we don't have any certificates, well, we can't validate anything, so we return false. And if we do have some certificates, we're just going to print them out here. But actually what we do is here is we will call sec trust get certificate index. These APIs are a little clunky because I mean this is the old, this core foundation APIs. But surprisingly, they're actually pretty nice to call from Swift. We had this code implemented before in Objective-C, and it was quite nasty in some parts. But writing it in Swift was pretty cool. Now, what we're going to do is now that we have these certificates, we're just going to we're going to load the certificate from our bundle. So we're going to get the path, and we're going to load a certificate. No, let's go and shortcut this for this one. So all we do is we just create on this data with contents of file, and then we call this method sec certificate create with data. And now we have loaded into memory. And now all that's left to do is we are going to check basically each one of the certificates we get in the trust, and if any of them matches the certificate we have pinned, we're good to go. And that's basically it. Now, one thing that's important is, if I get a match, I will return true here. And then, so basically, if evaluation is successful, I still do perform default handling. So what this does is, after I do my check, I still let iOS do its own checks that it would normally run. And the reason why I'm doing this, instead of just saying, oh, it's all good to go, we're good, is iOS will do some additional handling, like it will verify that the host name actually matches. Because, I could also check the host name myself, but it's just extra work. So that's basically it. So let's run this. And see what happens. Yeah, I see some errors here, that's good. All right, so what do we see here? So we see our code is being executed. We actually found some remote certificates. This looks, a certificate for the best website of all time. But it's actually issued by Charles Proxy CA, so that's kind of suspicious. And here's the root certificate. So yeah, that doesn't look good. And here's a certificate that we have loaded. It's issued by Let's Encrypt, which I'm familiar with because that's what I used. And no matching pin certificates found. So you'll basically get the request error with the code 999. Now, again, this app just doesn't really do anything interesting. At this point, it's kind of up to you to decide what you want to do. You could do a soft fail, so you could say, you could still allow things through, but you could let the user know, something is fishy around here, just be careful. Or you could just do a hard fail and say, I can't do anything, looks like you're around the middle, contact your, network administrator. So that's kind of like the hard decision. I can't really help you with that. It's really different for each app. So that went as expected. Any questions about this so far?
How, I'm not familiar, how the certificate, this Charles proxy, for example, how it is found? It is looking the first one available, or You know, there are so many CAs, I don't know, hundreds or something, yeah? So which one it is given to the application to be certified?
So okay, so there are only like two CAs that are at play here. So one is the CA that issued the legitimate certificate for my server. That's the Let's Encrypt Authority, and the reality is yes, there are like hundreds of CAs, but in reality there's probably, well, I don't know how many, but under 100 of like root CAs, and they're the ones who sign everything else. So it's like basically a chain. We're going from the root to whatever the intermediate CA, there's probably some intermediate cert as well, to your server. If that chain is broken, then basically we got SSL failure, or HTTPS failure.
Now, in this case, I think you have told your system to send the traffic through Charles, right?
Yeah, Charles has a
gets
transparent proxy set up. Yeah, so it actually changes my proxy settings in macOS.
So that's how it's seeing the Charles certificate instead of the real one, right?
Yeah, that's right. Yeah. But I mean, in sort of like in a real world attack again, so like in the Bluecrypt scenario, they're already running transparent proxy in the network. In like a rogue certificate authority scenario, it's either the government that's doing DNS poisoning like at the ISP level, where it's sending you, instead of resolving this DNS to my website, it will resolve it to another website, and then that will have a fake certificate. Again, it's usually whoever is owning the network or whoever is owning the ISP that does that. And you can extrapolate this into kind of like dark future where, that's dark future indeed. So you can extrapolate this to the dark future where, for example, in a certain country like Russia or Iran, in order to get on the internet, you have to install the ISP certificate. I know it sounds dark, but we're kind of unfortunately we're going there. So anyway, let's get back to the program. We still have a few things to cover. So there are some issues. The biggest issue is, so you have the certificate, great, like what happens when it expires? That's actually like a big pain, right? So what you could do is, you could just update the app beforehand, before it expires. So for example, you know that your certificate expires in half a year, you create a new one, bundle it in the app, and you have like two certificates, and if either one matches, you let it through. But it's cumbersome. It makes code complicated, and if it's complicated, there's bound to be bugs. And some people don't update the app, so they'll run like 2-year-old version of the app, and then now you're screwed. It's especially a bigger problem now that all certificates have a maximum lifetime of like 2 years. So it's just extra work that you don't want to do. Okay, so this brings us to version 2, new and improved. So what we can do is we can use public key instead. So I'm not going to go into sort of like the details of certificates and public keys and CSRs, but the way it works is you basically create you create your private key first, then based on that you create a certificate request, and then that certificate request then gets sent to your CA, and then they give you the certificate. So what you can do is the public certificate portion will contain a public key, and all the keys, all the certificates that are generated using the same private key will have the same public key. So what you can do is you can pin the public key instead, and then as long as you have that original key and you generate new certificates using that key, it will work. So this brings us to demo number 2. It's actually pretty straightforward. Let's see what changes we have to make. So the rest of the app basically stays the same. Instead of the certificate, now I have my public key also in binary format. Here. And when I'm doing my pinning, there's a few, this part is still the same, so we still evaluate the trust. Now this actually becomes easier because now we have this handy method we can call, sec_trust copy public key from the server trust, and this will actually automatically return you the public key of the leaf certificate. So it doesn't matter if you have a large chain, you don't have to like sift through it. You just get the leaf key automatically, which is great. So you have the remote key now, and now it's a matter of, again, loading, getting the path for the file and your resources. You load the key, and loading the key is, again, you just create this data. You set some attributes, so we know this is an RSA key, and this is a public key, you call the sec key create from data. This is actually really straightforward, but this method was only added in like macOS 10.12 and whatever the iOS equivalent of that is. Before that, it was quite cumbersome, so I was surprised when I found this. I was like, I wasn't really looking forward to showing code for that, but you know, I did later. So anyway, I'm not going to run this, but the idea is basically the same. So instead of comparing certificates, you just compare it. It's all good. So let's go back to the demo. Okay, so there are still some issues with this. So we have to use the same public key. What if it gets compromised? So again, like what if I email my card keys to somebody? Oops, that's not good. What if you want to change crypto? So right now, basically, RSA is all the rage. So normally, when you just generate a certificate by default, you will see, you know, RSA is the option. But now, the kind of like hip new thing is elliptic curve cryptography, which is ECC. Again, I don't know enough about crypto to talk about this in detail, but I know that supposedly it's more secure. It's supposedly quantum proof, and most importantly, it's usually less compute intensive. So it's good. So, but if you're using the same public key, you can't use it. So you basically need to switch over. And another really important thing is you might not want to expose your public key or your public certificate for that matter. And I know this sounds a little paranoid, but like in countries like China, it can actually be used to make deep packet inspection easier. So even though this is kind of public information, you might not want to expose it like ahead of time. So like, for example, yeah, sure, you still have to have your public certificate, but if you pre-made a bunch of them, you might not want to show them kind of like in advance. So, one other thing is, this is right from certificate pinning guide. Yeah, implementing pinning validation from scratch should be avoided because, you know, again, we are all people and it's very easy to make mistakes. Sometimes it's really hard to notice them. So, true story, when we implemented this, again, we implemented certificate pinning first, then we switched to public key pinning. Our code was quite complicated, like, you know, it was doing a lot of things. It was also Objective-C, and I was the person who reviewed the change, and I approved it, gave it a big thumbs up, and then, you know, I decided to check because our certificate was about to expire in like a few months. I decided to just double check to make sure everything works. Sure enough, it didn't. So what we were doing is we were doing the public key check, and then we were following through, and we were also checking the certificate. So, oops. So we basically broke all of our apps. Good thing that I did the check. We still had about 2 months to push out an update. We had to do an email blast. We had to do like an in-app kind of like banner, like urging people to update. It was not fun. So again, even though the logic might look straightforward, there's still opportunity to screw things up. So what do we do? Pinning version 3. So what you can actually do instead is you can pre-generate several keys, keep them private, and you can provide this thing called SPKI hash. So SPKI, it's the special field in the key. It's called subject public key info. So it combines your public key, algorithm, and a few other things. And you just take that, you hash it, and use that hash. And again, people smarter than I deem that sufficiently secure. So if a key is compromised, while you just generate a new certificate using another key that you already have pinned, that you already have a hash of, and hopefully sometime down the road you update your app to include yet another hash. You can replenish your supply of hashes. And best of all, there's actually a very good pod. It was created by, I believe, by people from actually 4 places. I think it was PayPal and Yahoo. But it's good. It's called TrustKit, and it does all that for you. So the demo is going to be very short. Let's see. You know, when I saw this, and I actually saw this like after we spent already some time playing around with this, I was amazed by how little work you have to do. So let's actually just go back. So I don't have to include anything in my resources, which is great. Now in my app delegate, I have to initialize TrustKit. And what you do is you kind of initialize a shared instance and you specify the parameters. TrustKit is super flexible, so you can set up different pinning for different websites. There is a lot of like optional parameters that I don't have here. But for example, here we're saying that yes, we have a pin domain. Here's the key algorithm. Here's some keys. And actually, it's smart. If you only give it 1 hash, it will complain. So it will actually make you have backups, which is nice. I mean, you can still lose all of them, but you know, at least it's something. And then that's pretty much all you have to do. So you initialize a shared instance, and then my all other code is still the same. And in my challenge handler, I just create the trust key validator, and I tell it go handle this stuff, and that's it. So that's much easier than writing code yourself. You know, I could have just showed you this, but it wouldn't be as interesting. Plus, also, I think it actually helps. I think it helps to go through the code yourself to kind of understand what it does at the conceptual level before you kind of say, oh, you know what, I'm going to trust everything to this pod that doesn't even know how it works. But my recommendation would be to use TrustKit. And that's basically it. So there's a few kind of concluding thoughts, remarks, topics. There's still some remaining issues. So the problem is if your app relies on third-party sites, you're still kind of screwed because, yes, you can extract the public key or certificate, but you're not guaranteed that the owner is going to use the same public key, or they're going to give you in advance the hashes that they're going to use. And we actually had it happen on Amazon. So we tried, you know, public key pinning, and they renewed the certificate with completely different public key. It was actually a completely different intermediate certificate and a different root certificate. So yes, pinning third-party websites still is a problem. Yes, and even if you have European keys, you can still lose all of them, even your backups. So you know, it's up to you to kind of have like a sane system of backups. Now, in the future, there are there's new development called certificate transparency. Certificate transparency apparently was actually added in iOS 12, and it will be automatically enabled for certificates issued after October 2018. So I think when you issue a certificate you're planning to use in Safari or in your mobile app, I think there's like an extra step you have to go through. I don't know a lot about it because I literally just learned about it this week. And it remains to be seen how it will be adopted. But in theory, at least, it kind of gets rid of all the sort of like you won't have to worry about certificate pinning. It will kind of take care of that. But you know, it's yet to be seen how it's going to work. And if you still have older certificates, you should still do pinning. Now, that's it. So just a couple concluding slides. And I'll make the slides available. I'll also make the demo available if you just want to work through the code. Some of the resources that I found were useful. The most useful is that OWASP, the security certificate and public key pinning guide. Even if you're not going to do pinning, I think it's a good read. It has a lot of information you need. Apple has a technical note about you know, like the challenge handler, and they discuss a lot of things you can do. It's very dry and very technical, so it's not like a great read, but sometimes it's good. It's a good reference. And if you want to know more about things like what is this SPKI and how to actually generate SPKI hashes, I found that this blog had a good article about that. And finally, before we jump into discussion, I want to say big thanks to my coworkers, Marcus Ospassky. He started out as a co-op and he became kind of like a senior developer in our team. He was responsible for implementing, kind of like doing the hard work of actually stumbling along and implementing certificate pinning and, trying to find information how to do it the right way. Curelet-Balan, he joined a little bit later and he provided a lot of insight and lots of code reviews. And Kayla Deveron, she isn't even an iOS dev, but she kind of pulled everybody together and really rallied us around certificate pinning, kind of re-energized us, and which is why we kind of like finally came up with a good implementation. So big thanks to them. Big thanks to Matt for basically making this meeting happen. Questions?
There's pizza coming at 8 too, so before hopefully.
I have a question.
So,
do you know what are maybe some like performance implications when kind of implementing this additional layer of security when it comes to like networking and the apps itself?
well, I mean, there's always going to be some performance penalty for doing extra work. I mean, obviously, like the code that I have there is pretty atrocious in the sense that for every security challenge is going to load a certificate, and this is where you should probably like load it once and cache it. I think the comparison itself is not significant, and I mean, in our apps we haven't really found any significant difference with being enabled or disabled.
And do you know, one other question, do you know how often is that delegate method called? Where we let the trust kit do its thing?
So it's a good question because I find that I couldn't find a lot of information. It seems like it doesn't get called with every request, but it gets called pretty often. So I'm not sure if there is some kind of caching happening or some kind of I don't really know enough, to be honest. But that's something to look into.
In this URL session, we'll set up the SSL connection and kind of keep that going for a period of time. So imagine when it initially makes that connection, it does that check and then it kind of lasts for as long as it's maintaining the connection.
Okay, I see. So theoretically not often.
No, but again, you should count on basically, if you're going to implement it yourself, you should probably not do stupid things like loading the file every time. But again, actually we have done this, and even by loading the file every time when this method gets called, we didn't see significant things. Like our app is not great, but like our app is pretty chatty. So I mean, your mileage may vary. I mean, one question you should ask is well, okay, so do I have to do it? Again, there's opinion is split. I think if you talk about if you talk to hardcore security researchers, if you don't have certificate pinning, they see it immediately as a high level security vulnerability. Again, I think the kind of rule of thumb is if your application communicates with your backend and it transmits any data about the user that is potentially personally identifiable. So, for example, my demo app is a really good example because it sends in location data in real time. And on one hand, well, the user doesn't log in, right? It's just some location data. But you have location data and you have the device IP, because every server has the device IP. You can take this information and you can find out, what ISP I'm using, and you can go to an ISP, start cleaning them, get them to find out which device was using that IP at this time. And in Canada here, I think the ISP has to keep the logs for at least 6 months. And so it depends on country by country. So basically, if you're a government organization, law enforcement agency, or somebody else, you can tie that data to the user. So this is a good example, I think, for using certificate pinning. But it's really up to the developer to figure it out. It's one of those questions it's a product question. I would say, again, it doesn't seem like there's a lot of disadvantages, especially with having multiple keys and providing the hashes. I don't really see a reason not to implement it.
What gives you the confidence that this implementation is right?
trust kit. Yeah, so I mean, you don't know, right? But it's been used by a lot of people. It's been vetted by some security researchers. Security researchers that like we deal with, they mention that library. So and understanding how it's supposed to work. I mean, again, this code is out on the internet, so you can go check it out and kind of tell yourself that it works fine. So, you know, without doing like a formal verification method, you never know for sure. But you know, again, it's like how do you determine whether to use a library, like a third-party library? Well, look at it. Is it popular? What are other people writing about it? Can you look at the code? Does the code look good? Is the documentation good? You know, you never know for sure.
How you test your stuff?
We just kind of see if it works. Yeah, again, like we don't really have like a formal verification method. What we do have is we have a company that we hire to do like an annual security audit where they actually go in and we give them access to our source code for the clients, for the backend, and for the infrastructure, and they go at it and they try to find as many issues as they can. So on top of like developer testing, that's what gives us some confidence that this stuff works. And they give us really hard time for the most minute things that you can imagine.
So you cannot do like unit testing for specific stuff?
So you can do unit testing. I mean, there is kind of only so far that you can get with the unit tests, particularly with certificate pinning. And it's a good question. I think when we had this problem with screwing up pinning in a bad way, we were kind of thinking about how to test this. And we didn't really come up with like a good answer. Other questions? Yeah.
So that debug tool that you used that was basically able to sniff the
Mhm.
traffic.
Yeah, I did.
Is there ever a way that somebody could effectively run that on their device? Like if I wanted to, say, load up an app that I know does some secure communication,
Mm-hmm.
and I wanted to figure out what protocol, what messages are they sending across the line, could I theoretically set up my iPhone?
Sorry, just a second. I gotta get the pizza.
Sorry.
Yeah. There's also one other tool that I would recommend if you're interested. There's also a command line utility called Mitten Proxy. It's Linux. That's the one I use. Oh, yeah, I used to use Proxy app, but unfortunately I think they went out of business. Yeah.
So with that in mind, if you fail to implement certificate pinning and you're basically open to this attack, so to speak, if somebody wanted to, say, reverse engineer an API, because nothing's really stopping them from communicating with your public server IP.
Mm-hmm.
So if you wanted to then prevent somebody from sort of sniffing or reverse engineering your protocol, I guess you still need additional security on top of the certificate pinning between the communication channel. So for instance, let's say you write an activation server for CAD software,
Mm-hmm.
right? And you want to have a licensed activation server, and basically you want to write the simplest server as possible, and you just want to say, okay, go ahead.
Mm-hmm.
Well, if somebody sniffs out your protocol and figures out that, oh, I just have to respond and say, okay, go ahead,
Right.
they can effectively put their proxy in there and make my app think that it's talking to my server because their proxy, has now just faked the certificate and everything.
That's how pretty much, I think that's how like the iOS like App Store kind of hacks happen.
Right.
On the rooted devices.
Mm-hmm.
But again, like if you have certificate pinning, like in theory that should.
Right, certificate pin, but now certificate pinning effectively exposes those. Suppose we wrote the code exactly as you wrote it.
Yeah, I see. So you would get the hashes.
Somebody can just find the hash string, like look for something that looks like a hash, for instance,
Right.
and just swap out that code, because locality reference. You'll find those hashes next to, say, that constant for, your algorithm, your RSA algorithm.
Mhm.
And it's very easy for somebody to modify the binary of an app, say a
Yeah.
jailbroken device, modify the binary, swap out that string for their own hashes, and suddenly you're now sort of
Yeah,
like
I mean, at this point, you might as well just, like, if you're going to modify the binary, you might as well just modify the binary to disable that
to
check.
disable the check, right?
So, yes, it's, you know, if you want to prevent that, then you go to, like, binary obfuscation. It's-
Right.
Yeah. It's not, you know, again,
Or
it's
you
not-
go as far as like an HMAC between you and your server, where your server now has private key and is basically signing everything that's coming to you.
Mhm.
And at that point, I mean, same thing still applies. I guess they can inject their own public key and replace it with a public key.
I mean, it's kind of a rabbit hole. I think it depends on, like, how far,
The thing is that
You
all
know.
these approaches I'm talking about are very easy to implement.
yeah.
Like back in the day, so I'm friends with Gus Mueller, who does Voodoo Pad and whatever. And I kind of discovered this myself, that like, hey, wait a second, you know, if we're doing this license key validation thing and basically just working off of, you know, a public key that's embedded in our binary, couldn't I just modify the binary? And in like 10 minutes, I basically swapped out his public key thing with my own. I was like,
Right.
look, I just built a key gen and a crack for your
Right.
app. And he was like, holy crap. You know?
Yeah.
So this approach obviously requires some kind of obfuscation, I guess, to at least obfuscate, even if you just do a row 13 or whatever on
And
hashes or.
again, sort of like the common scenario is hopefully you're running iOS on a non-jailbroken device.
Right.
That protects you. But yeah, once you
Yeah.
get into the kind of wild west world of macOS or jailbroken devices, yeah, you're still.
It's macOS more than iOS that's a problem.
Yeah, that's true. Yeah, that's kind of, I don't know. It's a tough one. Which is why, you know, Mac App Store might be good.
Well, even the new the hardened runtime helps with that, because the hardened runtime disallows debug attachment and stuff like that, and is more
Right.
more picky about certain things like that. Like if you wanted to try and debug something that's already running on the hardened runtime, it's a pain. Like I tried to reverse engineer a hunk of iTunes, and it took me forever to like bypass all that.
Can you like enable it, disable it somehow, going through?
It's a pain. You have to like turn off system integrity protection. You have to jump through a lot of hoops.
I mean, again, if you're talking about security researchers, they're gonna do all of that. Like if
Yeah,
you're talking
yeah,
about
yeah.
script keys, then yes, that's
Right. It just, you know, pirate's gonna pirate, and you know, you want to find the lowest hanging. Like certificate pinning is already making it quite a bit harder.
yeah. And then,
Obfuscating the certificate makes it even harder still. You know, basically, if a cracker needs to spend more than say 2 hours trying to find the place that they need to
they might as
attack,
well just
they're just gonna be like, next.
yeah, that's right.
But yeah, those are the things that keep me up at night.
Oh, one other thing that I forgot to mention about this, I should have had it in the slides because it's important. So this, this challenge handler, it doesn't actually work in the web views. And I know in the old web views, like UI web views, there was some talk about like, I don't think it was possible at all to do certificate pinning. I think in the new, what there was called the Safari View Controller,
That's not surprising.
yeah, I think there's a way to have that challenge handler, but to be honest, I haven't looked at it because we don't use them, and yeah. So that's something to be aware of.
I thought Safari View Controller isolated you as much as possible from the whole.
Yeah, I don't know enough about it.
WK might have.
WK might,
Yeah, it probably does.
but SF Safari View Controller basically obfuscates the whole, basically everything. It's almost like a fully remote view controller.
So you might not
Because
be able
what
to-
people would do with it is, if you were like authenticated to a web service on Safari, if you embedded SF Safari View Controller, you had all the cookies and passwords and whatever from Safari.
Yeah,
So I don't know if they give you that flexibility.
yeah. So that's something to look into. But yeah, so that's basically it. Anyway, I hope you learned something from it. Again, you have all different use cases. I think it's up to you to figure out whether you need this stuff. But again, I think you have to think about this in reality, like, you don't really think about these things because you're in Canada. We're fairly liberal country. We enjoy lots of luxuries that other people don't have. Number of users. We have a lot of people in Turkey, Russia. Like, it's really depressing what's going on there. Obviously, there's China. There's a lot of efforts by governments to collect information about the users, and they'll stop at nothing to do that. So any little bit you can do helps, I think. So that's it. Thank you very much. And pizza should be here in a minute.
Can you click on the trust kit, like view the source for trust kit? I just want to see the author name on it.
Okay, well, hold on. Oh, wait, what happened here? Okay, we can get to it. So I think that's one thing. I think the trust kit is actually Objective-C. No.
It'll be in there. There's your source. Oh, just any header.
Trust kit project authors. I know I think there was like literally 2 views.
Oh, there's an author spot.
Yeah, probably on GitHub.
That was just over here.
It might not be included in the college.
Okay.
I have a hunch about some of the. Data there in that sense.
Others. And I thought that was somebody from PayPal. Maybe I'm wrong.
So there's another one of these out there. Written by a guy, I'm forgetting his last name, Rob, I say either Rob Pike or Rob something else. I think he used to work at RSA.
Oh, okay.
Yeah, he's a ex-security researcher who now does iOS development, and he's been doing a lot of consulting for people and finding that this was a common thing. So there's another one up there too. We're gonna dig around.
Yeah, that's again, I mean, pick one that you trust and go with it. Let's enable the lights.
Yeah, the WKW does have that as well. It's a challenge, I think.
Oh, it does.
The WK, right?
Yeah, the
okay.
WK,
Yeah, right. So you still have to use that.
but
Safari view controller gives you almost nothing. You can't even dismiss the view controller.